guys doing? You've had a few more classes since I saw you last. Is everything going okay? Yeah. Okay.
So far.
So far. Exactly. Exactly. So far, everything's great. We'll see. If you don't forget, in Canvas, I've got information about different services on campus and so forth. So if you ever have, you never have to give me more information than you want to. But if you ever experience things that are making keeping up with stuff difficult or whatever, you can sort of give me enough information so I can figure out what resource you might need to go to, right? Because there's a ton of resources here that are free for students, so it's just crazy not to take advantage. So there's no questions. We're just going to jump right back into finishing up this warm-up sheet. Oh, okay. No more purple. Oh yeah, we did this one. Okay, good. And no, I do want to say, this class obviously is all about trigonometry. And I'm not even sure, some of you guys might not necessarily know exactly what the hell that is yet. You really need to start talking about it. But these algebraic concepts will show up every now and again. It's just not going to be like overt algebra in your face. It's going to be basically about angles and sine waves and such. But who remembers this idea? Yeah, what's the idea?
Anything raised to the 0th power is 1.
All right, cool. Does anyone know why? So we know why when you raise something to a 0 power, you get 1. I like it. That's weird. Why the shit would that be true? So in mathematics, one thing is to know what to do. The other thing is to know why you're doing it. And I live for the why the hell do we do this question, right? I want you to have some idea of what the idea is behind what it is you're doing, not just he said to do this, right? So real quick, help me out. Does you remember what x to the 5th over x squared would be, for example? Because the idea there is you subtract. Why do I subtract? Because if I have 5 x's divided by 2 x's, I lose 2, so of course there's 3 left. Ooh. So when you have dividing like bases, you subtract the powers. It's just a shortcut, right? If I had x to the 80th over, so I don't want to write 80 x's. Let's make a shortcut, right? So help me out. What would x squared divided by x squared be then, applying that rule?
1.
No. Apply the rule. X to the what? What do you do with the powers? Subtract. So what do you get? 0. Now come at me. What is something divided by itself? 1. Okay, so anything to the 0 power is 1. You guys, one thing that doesn't follow that rule is, of course, 0 itself. Very quickly. What is 0 to any power?
0.
What is anything to the 0 power? So what? No. So what would 0 to the 0 power be? Both of these somehow. Do you see that? Weird guy. We won't talk about him anymore. Go away. If you did go on to take calculus, for example, and some of you guys, anybody, calculus is in your future for anybody? You will actually talk a little bit more about 0 to the 0. Right? It's an interesting thing. We're just going to let it be. Right? Okay, so what's being raised to the 0 power in the first term? Good. What's the 4 being raised to? What's understood to be on the 4?
1.
A 1. So I get 4 to the first times x to the 0, and what's x to the 0? 1. What's being raised to 0 power in the second term?
That's the 1.
It's the whole damn thing. Anything to the 0 is 1. Shmup. So I get 4 minus 1, which the last time I checked was 3. I like it. Is that cool? I understand why people think this is 1, but again, the 0 can only go so far. The parentheses are what helps exponents go further. Okay, I like it. Okay. Now, in all honesty, there will not be a ton of factoring. There will be some, for damn sure, but not a ton. I just want to see who remembers how to do these things. I'm not going to spend a lot of time reviewing. I just want to see where you are with how to do these. Does anyone remember how the hell I'll get us started? Yeah.
Well, you know that x squared has to be x times x, and since 10 is negative on the end, you know it's a negative and a plus.
All right, so real quick, you know x squared, x times x, kick ass. Now you need two numbers that do two things. What are those two things? They must multiply to be negative 10?
Yes.
Because the middle term would come from those combined, correct?
Yes.
So again, almost everything to do with mathematics is just noticing a pattern and then applying it backwards. So, what two numbers multiplied to negative 10 had to be negative 3?
Negative 5 plus 2.
Negative 5 and 2, I love it. If that would have been a plus 3, it would have been positive 5 and negative 2, right? Just the bigger one is whatever sign you want to have at the end, right? When they're different signs. So it doesn't matter where you put it, minus 5 plus 2, that's an answer. Plus 2 minus 5, that's an answer. Because 7 times 8 is the same thing as 8 times 7. Commutative property, right? Just to be overly technical. Okay, how's that? Is that coming back to everybody? And again, like I said, there will not be a ton of factoring. When we hit the part where there's factoring, I'll review it some more. But I just want to see kind of where everybody is. All right. I'm personally not religious, but I like to call x squared minus 16. I like to call this kind of problem a thank God problem. Does anyone remember? The name doesn't matter as much as the process, but does anyone remember what that kind of thing is called? Okay, it's got perfect squares in it. Difference of squares. Kick ass. I like it. X squared is x times x. 16 is 4 times 4. The middle term is 0. So if I apply the thought process from the first part, I want two numbers that multiply to negative 16 and add to be 0. Yeah, so they have to be the same number, different signs. So if I see two terms, it can either be squares, which means cut everything in half, or cubes, which means cut everything in thirds. So this one, I call it a thank God, or a thank the God of coffee, or a thank Flying Spaghetti Monster, or whatever deity you like, because this is easy as shit, right? Cut x squared in half, cut 16 in half, opposite sign so that the middle term cancels, right? Now just to show you what I mean by it's always easy, look at this thing. You ready? What the shit are you doing, Jeff? Sorry.
I want to see.
Sorry, I'll show you. All right. How many terms are there? Wait.
Well, we can see it. There we go.
I can't control this guy. How many terms are there?
2.
2. So it can either be squares or cubes. Is there any GCF? Is there anything that can come out of both terms? Nope. So it's either squares or cubes. If I can cut things in half, it's squares. Can I cut everything in half? And what do I mean by cut it in half? I don't mean that's 12.5. I mean cut it in half multiplicatively. What would 25 be then? 5 and 5, right? So can I do that to everything? Yes. If that was w to the 9th power, it would officially not be a squares because it can't cut 9 in half nicely. Do you guys see what I'm saying?
Mm-hmm.
This everything I can cut everything in half. So how do I do this? Cut it in half. 5. Keep going. A b squared. So there's another 5ab squared. Do you see how that's half and that's half, and together they make a whole? Oh, right? Mm-hmm. Minus plus or plus minus, who cares? And then cut this guy in half. 7, W4. 7, W4, Y5. So this becomes a whole one of these, this becomes a whole one of these, and the middle terms kill each other. So if it's 2 terms, everything can be cut in half, you just go, thank you, Jeff. And then you just cut everything in half, plus minus. How's that? Okay. What about this guy? It's this little jackass here. Look at this guy. Wait, like here. Sorry. That one is more difficult than you think. The answer is definitely not x plus 2 cubed. Because you'd have to write x plus 2 times x plus 2 times x plus 2, and when you do all the FOIL distribute, when you get a lot more terms than that, so that can't be the answer. So I don't know if you guys, anybody remembers how to do this. Yeah.
So I got x plus 2 times x minus 2 squared.
Oh, I like that. It's not quite right, but I really like that thought because you're thinking like I need some negatives to make some shit cancel.
Yeah.
If you multiply that out, it won't work. Yeah.
You wanna know what I got?
Sure.
I got x plus 2, x squared minus 2x plus 4.
Intriguing.
What immediately comes to my mind is to cube root it first.
Oh, okay. Several things. Is this an equation? So I can't cube root it because then I've changed the problem. If I had an equation like x cubed equals 8, I could cube root both sides. And the fact that there's two sides allows me to do that.
Mm-hmm.
This is not an equation. So it's sort of like me saying, okay, here's 27. You're like, I'm going to cube root that. No, it's 27. You can't just cube root it. You've changed what it is, right? But cutting things in thirds is a good idea. Because what did we do here? Didn't we cut everything in half?
Yeah.
All right, let's cut this in thirds. What's x cubed?
X,
X times x times x. And what's 8? 2 times 2 times 2. So just to, oh shit, in half. Sorry. I don't know if you can notice, I don't like doing this, but anyway, I'll try. So here's what works. Just gonna cut to the chase. Whenever you see accused, little dude, big dude. And you'll see why in a minute. Little dude, he's a little dude. You can only put so much shit in the little, he's a little tiny dude. I know, I'll stop. So I can only put one x in the little dude. Plus 1, 2. So that's a lot like what we did here, yes?
Yeah.
I put 1x and 1, 4, and then the other 1x and the other 1, 4, correct?
Mm-hmm.
So here, if I put 1x there, how many x's do I put there?
2.
If I put 1, 2 there, what do I have to put at the end here?
2 times 2.
Don't I get my x cubed?
Yeah.
Don't I get my 8?
Yeah.
Why did I leave room then? Because don't I also get 2x squared? You see that?
Yeah.
Let me kind of zoom out. Okay, there we go. All right, let me stop for a minute. I really want you guys with me. What I have so far seems beautiful. 1x times 2x's is 3x's. 1, 2 times 2 2's is 3 2's. I get 8, right? Everything looks beautiful. Except I also get this stupid term. I don't want that stupid. And then I also get freaking 4x. I don't want any of that shit. So what I've got written right now cannot be the answer because it gives me more shit than was there. So very quickly, has anyone ever seen the movie Pulp Fiction?
Yeah.
There's a scene, kind of famous, guy in the back seat. Something happens, makes a mess. So they have to call the dude, the wolf, right? What's his job? He had to clean shit up. So the middle dude is the cleanup dude. It's going to clean up all this shit. I keep pointing over your heads because there's a TV there. It's going to clean up this. So help me out real quick. What could I put here? What would cancel this?
Minus 2.
Negative 2x squared. X times what is negative 2x squared? Negative 2x. Now let's check. So that would get rid of this. What else do I pick up? What's twice negative 2x?
Negative 4x.
Holy shit! It kills everything. What the hell? Thanks for that. I like that dramatic. Dun dun dun! Notice this. Isn't this exactly this times this? The middle term, isn't it this times this? Always. Always. One of each, two of each, product in the middle. That's the closest I'll get to making a song. All right. And then there's one, I don't generally like mnemonic devices, but here's something. This sign is always the same, plus plus. This sign is always opposite. Why does that make sense? Because it's got to cancel stuff out. And this sign is always positive. And one reason I like this mnemonic device is it goes along with Pulp Fiction. You needed some soap in that scene. Huh? Soap, right? Soap. Let's try one more out real quick. What about y cubed minus 27w cubed? Two terms. Any GCF? Anything come out of both? Nope. Two terms. It could either be squares or cubes. This is very obviously cubes, okay. Because if I would have made that a 25, it wouldn't be anything. I have to either be able to cut everything in half or everything in thirds, right? Okay. So what's y cubed? Expand that. Y. Maybe y. No, Jeff, you did not do that. And then 27w cubed.
3W.
You're good. 3w, 3w, 3w. People hate cubes because it's the one you have to memorize the most for, right? The other ones you can kind of sink your teeth into and work it out. It's like a number puzzle. This one you got to memorize little dude, big dude. What am I going to put in the little tiny dude?
Y minus 3W.
1y, same sign, 1 3w. So of course the other two y's go here. What goes at the end?
Plus 9W squared.
Good. The other two 3w's. We stop for a minute.
Plus
1 of each, 2 of each. What's the sign of the middle term going to be?
3.
Sign of the middle term.
Plus.
Plus, so that it can cancel shit out, right?
Mm-hmm.
And then what is it?
Plus 3WY.
3w's. Always just whatever the hell you put in the little dude, multiply it. First question is, does that seem familiar to anybody? Anybody remember doing those? Second question is, if you don't, does that make sense? Okay, all right. Third question, if it doesn't make sense, could you do it? All right, I really want to make sense, but you know. All right, sorry, let me leave that there for a minute. So that is the warm-up sheet. And again, algebra will come in every now and again. As we hit some stuff, I'll do a little quick review. Mostly we're going to be working, of course, with angles and trig functions, whatever they are, and all this kind of business. But algebra is going to be involved every now and again. Okay. Any questions about that whole sheet or what we just did here? Okay. All right. Okay. Just to let you know, if you guys can help remind me, we do have I'm going to take you like on the smallest field trip ever. But there's some really cool shit I want to show you in the building. So I think our class ends at 10:50, right? So think about 10:30, we're going to head out. So I'm going to try to remember, but if you guys notice, you can just go, Mr. Wallace, shut. No, it's just, don't forget. I'm like, oh shit. Okay. So now I want to transition to actually getting into some trig, which would be great, right? Sort of like Jeff Goldblum doing the whole, will there be any trig in this trig class? Thank you for somebody getting that. Exactly, that's thank you. I hate that, man. Okay. I think that'll work. So let me first turn this guy off so it doesn't freak anybody out. Let me ask you guys, angle. What's an angle? Yeah. Oh, okay. I like that. Somebody's going like that. Kick ass. What does it take to create it, to draw an angle? What do I have to actually... But one of the draw, yeah, not two lines. Because what's a line do? A line goes forever in both directions. Let me ask, some of this is going to be like basic geometry that's not going to matter that much, but I just want to kind of refresh your memory. When I draw a line, I have to put arrows on both ends because it goes forever in both directions, correct? So if I identify 2 points on this, I can call this line AB. Does that look familiar to anybody? What is it called? And the name doesn't matter as much as just being able to draw the damn thing and work with it. But what's it called when I don't go in? I only go in forever in one direction.
A segment.
A ray. A segment is that stops. It doesn't go forever in both directions. It just, yeah. So this would be, if I identify 2 points on it, this would be ray CD. And of course, see the top is only one arrow. It's crazy. All right, so far so good, right? Okay. And like you said, though, if I had a little segment that doesn't get very far at all, let me give it different. There we go. This would be segment EF. So no arrows. I can't remember if you put little dots in there. I like it. So this is really getting like down to really crazy basics, but to create an angle, I put together 2
segments.
rays, to be honest. Real quick. Can you very quickly right now, don't say anything, just try to create a 45-degree angle. Let me just throw some stuff at you. Can you just draw a 45-degree angle as best as you can? We're not human protractors, I understand. Unless you are, in which case I want to talk to you. Are you? No, it's all right. Yeah.
So you can't do 2 lines, like when we're answering.
Not lines, right? So I like, you could do this. That's a what now?
That's a 90 degree.
90 degree, and then you just kind of cut it in half, correct? So if I just want to draw a 45-degree angle roughly, what did I just draw? 2 rays, kick ass. And the idea is, does it matter how long this goes? Would that change the angle? No. And that's the neat thing about angular movement. I don't care how far away the moon is, for example. It could go through an angle as it moves across the sky. Are you with me? I can see a star, and I can see its apparent motion as it moves. And of course, the stars are moving. And then, of course, the stars are moving, blah, blah, blah. Not astronomy class. So I put 2 rays together. Let's just call this, I'm going to try to do what the book does here. I can't remember. I think the book does something weird like this. So that is roughly a 45-degree angle. How would you identify that using a name? How would you identify this angle?
BCA.
I love it. So you can either say, so we use, incredibly enough, we use this symbol for angle. BCA works. Somebody else give me another way to reference that angle. ACB. So you guys have picked up on something very important. It's the C's got to be in the middle, right? What's the best way to identify this angle, to be honest? Anybody know?
It's an acute angle.
Oh, it's acute. Yes. So, all right, since that came up, that's the type of angle it is. It's not really its name, because there's a lot of acute angles. What's acute mean?
Less than 90 degrees.
Between 0 and 90. I like it. Yeah, if I can just call this angle C. That identifies that. I like it. Kick ass. Now, what is true about this angle that I asked you to create? What's true about it? I asked you to create what kind of angle? 45 degree. How would you write that fact in math? That's a weird question. How I would do this, I would say, I would pick the way I want to reference this angle. So if I want to use this, I would say the measure of angle C is 45 degrees. I wouldn't say necessarily angle C equals 45 degrees. That doesn't make sense because angle C is a name. It's not a quantity, right? The measure of angle C is 45 degrees. I could also say the measure of blah, 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 blah. Okay, whatever, however you want to identify. In algebra, what are the main variables that we use to identify numbers? Huh? X and Y, right? And then you can use other ones that vary, but those are the main ones, right? In trigonometry, in geometry, there's a specific variable we use to identify angles. Now we could use more than that. Theta, I like it. So that would actually be there. Right? So in this case, theta would equal 45 degrees. Theta is actually the angle, not the geometric shape creating the angle. Right? And again, this is really detailed. Has anybody ever seen that symbol before? Or anybody never seen this symbol before? Right? It's just a little dude with a little extra curly Q in the middle. Right? Theta. You're going to see other Greek letters for angles. So you might see like gamma. You might see, what else? Beta, alpha. We also use capital A, capital B. We use anything that we want to, right? But the beta, sort of like XY, It's your basic algebra stuff. Theta is your basic angle variable. Okay. Let me make sure I don't forget anything. All right, so let's talk about this. Okay. So pretty cool with what we've done so far. Nothing too major. Yeah.
Is theta with an F or?
Oh, theta is Theta.
Oh.
Yeah. Yeah. I don't know if it sounded like I was saying feta cheese, but it is theta. Yeah. Okay. I like it. I'm pretty sure you guys have probably heard of alpha and beta. Unfortunately, maybe because alpha male, whatever shit. Right? I'm a sigma. Shut up. Sorry, it's funny. Gamma. Some of you guys might have heard of gamma, especially like Incredible Hulk, gamma rays. Anyway, okay. So you've heard some of these words before. You might not be familiar with their actual symbols. How many? So if I have a circle, that's pretty good for me. We've kind of arbitrarily chosen. In fact, we didn't choose it. We stole it. How many? What's true with the angle measure?
360.
Why?
Because it goes in every direction.
Huh?
It's because what math says.
I like that's what math says. Is 360 factorable in a lot of different ways?
Yeah.
If I was an ancient civilization, in fact, you guys are like, isn't this math class? Just go. If I was an ancient civilization, what's the most important thing to me throughout the year? When it's time to harvest and stuff, right? Food is major important, right? Now we can just go down and just do food and heal. 360, isn't that close to the number of days in a year? In fact, if I'm an ancient civilization, I might kind of estimate it'd be 360, because it's being another. So the Babylonians, all right, so very quick side note, okay? You guys all with me? Babylonians are who we stole some shit from. What's our number system based on?
Numbers.
Jerry, I love it. What's our logic system based on? Logic? Okay. 10, right? I don't know why it's 10. Okay. We don't really know, but it's freaking we got 10 figures. And doing this, 10 seemed to be the natural place to kind of like roll over. Like the odometer rolling over. The Babylonians used base 60 instead, right? How many seconds in a minute? How many minutes in an hour? We stole that shit from the Babylonians. Why did it have to be that way? Hell no. Do you understand what I'm saying? So these are little things you never really directly think about. There's no reason in hell that there has to be 60 seconds in a minute. Zero reason, right? Do you even know what a second is? I'm sorry. We measure a second now based on how long it takes a cesium atom to change state. So have you ever heard of an atomic clock?
Yeah.
That's what they mean. If you want to research atomic clock, they just mean keeping track of how often a cesium atom changes states. That tells me how many seconds have passed. So that's what it means by an atomic clock. It is perfect because that natural process can't change. It's rigidly set in place. More than you need to know, I apologize. Coming back to some, let's come back to some. So the Babylonians actually said there's 360 degrees in a circle because it's based on a year, which was stupid important to them. It's easily divisible a lot of different ways. It could have been 400. Do you understand what I'm saying? It could have been 2. It could have been 1 degree, Do you guys kind of get what I'm saying? 360 is completely arbitrary. It's just kind of a nice number. This is really important to understand why we use a different measurement. It's sort of like the rest of the world uses metric. Americans are special. We use feet and so forth. Do you guys know what feet and all that's based on?
Oh, that one dude's called.
The measurements of the King of England from a long time ago. Didn't we have a revolution? Why are we still using that shit? Sorry. Okay. So in trigonometry, we don't always use degrees. There's a better thing to use that is based on physical measurements, not some made up
let's use 360.
Right? So help me out. So obviously then, what we consider very often is these locations. So this is 0 degrees. What would this be? 90. So this is actually in here, but very often we kind of indicate it on the outside. What's this? 180. What's this? 270. What's this? 360. And then I can keep going, correct? If I go backwards, what's this? Negative 90 degrees, and so forth. I can go forward and backward forever. Yes? Yes.
Is that set like it's a set rule that clockwise is negative? Or-
Yes.
Oh.
And again, that's arbitrary. That, I don't want to freak out too much, but almost everything in mathematics, we just had at some point in history, we had to decide. So at some point in history, there's a decision to make. Which way do we go to consider positive? And for some damn reason, they went this way. We could have very easily said this was positive, right? I guess kind of, maybe? So roughly, what would this be then? Negative 45 degrees, roughly, right? Okay. All right, I like it. So let me ask you this. So if I had somebody standing and it said turn 180 degrees, where would it end up facing?
Backwards.
I would end up facing this way, right? What if I told somebody to turn 540 degrees? Where would they end up facing? What gets me back to here?
360.
360. How much further do I have to go? Yeah, so if I give you an angle measure bigger than 360, no? You could actually, because division is repeated subtraction, but as long as it's not too crazy big, you just subtract 360 until you get back to normal, right? So if I subtract one rotation out, then of course I end up with 180. So the location here has an infinite number of angles that will get me there. Does everybody understand what I just said? The most basic thing is 180. Couldn't it also be negative 180? Couldn't it also be 540? Couldn't it also be turn 7 times and then go 180, right? So it'd be 7 times 360 plus 180. Does that make sense? All right. Those are all called, let's see how I say it. I'll just tell you, coterminal angles. So 540 is coterminal with 180. Why does that make sense? Because if I spin 540 and I spin 180, I end up at the same place, coterminal. Where I terminate is the same as the other one, coterminal. So these are coterminal angles. I could just kind of go, but I want to make sure I don't forget anything. Yeah.
So the coterminal angles both originally end up it would be 540 and 180 because they both end up.
Yeah. So one pair of examples of coterminal angles would be 180 and 540. How many coterminal angles could you make with 180? Infinite number, right? You can just spin as many times as you want to. Is everybody kind of cool with that? Okay. Let me make sure I don't forget anything. Blah, 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 blah. Okay. Real quick, going back to the acute thing. So acute was between 0 and 90. Exactly 90 degrees is definitely called a right angle. What's between 90 and 180? Obtuse, kick ass. Does that sound familiar? I like it. So you got acute, then you got a right angle, and then you got obtuse. And that, we normally stop at 180 because anything bigger than that, here's what's funny. If I go beyond 180 degrees, what's another way to kind of like identify it is just to go backwards, right? Yeah. So you can kind of, especially in triangles, what is the biggest angle that could exist in a triangle? No, just a triangle. Yeah, 179.9999999. As long as you don't have 180 degrees. What would a 180 degree angle actually be? Straight line.
Yeah.
The minute you're a little less than 180, you can actually make this crazy thin triangle. Let me see if I can do it. Oh shit. So if I have so as long as I'm just a little bit, then I can make this stupid thin triangle. Give me a little board license on that. It's not easy. So it's like, it's this thin little triangle, but a triangle exists, yes? So part of this class, we're gonna, at some point, I'm gonna give you some information. I'm gonna say, could a triangle exist given these side lengths and these angles, right? Because you can't. So for example, if one angle's 180 or more, well, that's tough. You gotta make a triangle. Are you crazy, right? Okay, maybe. Yeah.
Well, didn't you say more than 180 you could technically make a triangle?
But if I wanted an internal angle of a triangle to be more than 180, that's impossible, right? So if I wanted, so does everybody agree this is more than 180 degrees? Can you connect this side and this side on this side with a straight line? No. I would do it this way, but then I'm talking about this angle, which is less than 180. Okay, good. All right, I like it. Sorry, I tend to get excited about stuff and I go beyond what you need to know. I want to make sure I don't miss anybody. Okay, cool. So we got acute, we got right, we got obtuse. What about, there's, if I have two angles that combine to make a right angle, does anyone remember what those are called?
Never mind.
No worries. Oh, that's a type of triangle. So we'll get to those.
It's not complementary?
Complementary. Kick-ass.
Oh,
Kick-ass. So, if I have a 27-degree angle, what angle do I need to put with that to make it a total of 90? 63. So 63 degrees and 27 degrees are complementary. Cool. Drawing that picture makes me remember something I wanted to say earlier. Let me put it up here right now. If I have like two angles here, right? So let me put this as A, B, C, D. Sure, let's do weird shit like the book does. If I say angle D, is that good enough? No, because that could be three things, actually, right? So in this case, if I want to refer to this angle, how would I do that?
ADB.
I'd have to use ADB. I can't do it shorter than that because angle D is not specific enough in this case, right? Earlier, why could I do it? Because I didn't have all that. I didn't have that. Now could I say angle D? All day long. It's not ambiguous, right? Kick-ass. I just forgot to say that earlier, yes.
You said the statistic of that line, is not angle D anymore?
No, real quick. Angle D doesn't make sense because that could be this angle, it could be this angle, or it could be this angle. I have to be more specific. If I mean that angle, I have to use BDC. If I just say angle D, that could be three things.
What would make it angle D?
Oh, if this wasn't there, that is angle D. There's no question, right? Or I could still say BDC, but I could also say angle D, because it's not ambiguous anymore. It's only one angle it could be.
Does the term complementary only apply to a 90-degree angle?
Good. Complementary angles are two angles that add to be 90 degrees. That make a right triangle. A right angle. Love you guys. What makes a 180? Supplementary. Here's something funny, ready? Math people, we call 180 degree, we call it a straight angle. Because we are weird as shit. But 180 degrees makes a straight line. So sometimes you'll hear it referred to as a straight angle, which is hilarious. Right? Okay. So supplementary, if I had 27 degrees, what would be the supplementary angle for that?
Oh, 27. I thought that said 2.
Together, so complementary, so I always remember alphabetical order. Complementary, 90 degrees. Supplementary, 180. So I have to have an angle that makes 180.
153.
Yeah, 153. All right, so let me throw some algebra at you. I said there wouldn't be much. So here's one place you can see some. So, right angle. I cut it, and this is x minus 1, and this is 2x plus 3. What is x? Don't say anything. Think about it. Or I could give you it without pictures. I could just say two angles are complementary. One is 2x plus 3 degrees, and the other one's x minus 1 degrees. What is x, right? So what equation can you set up?
2x plus 3 plus x minus
Yeah, so these two angles together have to make 90 degrees. And then you just have to solve that, right? Now this level of algebra, I desperately need everybody to be completely cool with this. How do you guys feel about solving this equation, right? What do you get? You get 3x plus 2
3x plus
88, and then we divide by 3, that doesn't come out nice, so we'll do it.
29.3.
Something like that. You guys kind of okay? I like it. I like it. There will be a difference between an exact answer and an approximate answer. Help me out. Somebody got a calculator? What is 88 divided by 3?
29.333.
Yeah. Because it's 1/3 more than 87. Is this, which one of these is exact? This one or this one? Which one is exact?
The left.
First one. This one is not exact. Now you could make it exact in this specific example because it is repeating threes. How do I indicate repeating threes forever?
A line at the end.
Yeah. Now they're technically both exact, but if I do 4 divided by 7, am I going to get something that has a pattern to it? Yeah, what is 4 divided by 7?
56.
5, 7, 1, 4. Yeah. Oh, somebody help me out. 4 divided by 7. Nobody's going to help me? You're all like, come on, math boy.
0.5714.
Oh, shit.
7 and 4.
Yeah,
I couldn't get more decimals on this. I'm not using the old calculator.
you're good. You're good. But it would never end and it has no pattern, correct? There's no way in hell to write a decimal answer that's exact unless there's a pattern to it or it stops, correct? So I will sometimes ask later this semester, I'll say, I need an exact answer. Exact? What the hell's exact? What is that? I need an exact answer and I need an approximate answer, right? People think this is exact when I write 0.5714 because your brain is like, well, 0.5714 is exact. No, it's not because I had to stop. That's an approximation, yes? Okay. Just want to make that point now so that when we hit it, it makes a little more sense. All right.
So you want both, so when you ask that, you want both exact and approximate?
Yeah, I'll be specific on a quiz or a test,
Okay.
which I want. And if I don't say, or the homework doesn't say, you could just give both like that. Then your ass is covered, right? Okay. All right. Yes.
We gotta give both, or can we just give one?
If I tell you the directions, which one? If I
Yeah.
don't say, I'll take either one, and you can just do both. Just, if you want. If I'm not specific, then obviously I'm not gonna hit. Ooh, you gotta guess. What's it gonna be? No. Okay. I can. Let's do this. Let's look at something a little bit strange. In this circle, there's 360 total degrees, right? If I take 1 degree, how much of the circle is that?
130. 1 over 360.
1 out of 360 of the circle. 1 degree is 1/360th of the circle, correct? Okay. Which is weird, right? That's just because we chose 360, right? It's just whatever we choose. The same way we break up hours into minutes and seconds, the really weird thing is, I don't know if any of you guys have ever gone boating much or anything. When you try to identify where you are, for example, latitude, longitude. You guys might know this. Latitude, longitude, you could break it down not just degrees, but you get more specific. So I could break each degree down into 60ths. What's 1/60th of an hour? 1/60th of an hour is a minute, because it takes 60 minutes to make an hour, correct? 1/60th of a degree is a minute. That's not confusing. It's kind of nice, right? So I don't know if you guys have ever heard, or if you ever use Google Maps or whatever. Sometimes you get very specific, like I'm at latitude 280 degrees, 14 minutes, 13 seconds, right? So that's getting stupid specific about what angle you're at on the surface of the earth, right? So 1/60th of a degree is officially 1 minute, which we use, this is really confusing, but oh well, we use that symbol for it, which, I don't know if some of you guys realize this is also a symbol used for feet. But oh well, we use that for minutes also, right? And then what do you think 1/60th of a minute?
1 second.
That's 1 second, which we use that. Yeah, it's sort of like inches, unfortunately, but oh, yeah, we're not very creative. All right, I like it. So, how the shit? Here's our first really computational heavy question. Well, actually, let's start off not too bad. Okay. So here's an example of what this could look like. Let's say I am at, let's say this is 73 degrees, 41 minutes, 29 seconds. So do you understand that would just be a little bit more than 73 degrees? I just turn a little bit more, right? 73, 74, there's a lot between 73 and 74. Minutes and seconds just helps me identify between there. Is that okay? And let's say that I go another, what, Jeff? I don't know, Jeff, you're making this shit up. Okay. We call this, yeah, let's do this. Let's introduce alpha. Let's say that we go through another angle of, what do you got, buddy? I don't know, 20 degrees, 8 minutes and say 52 seconds. Where is my ending location? How would you identify the angle that I end up at? Take a minute, try to do it. Realize something. What is 52 seconds plus 9 seconds?
61.
A minute and a second. Yes? Do you understand what just happened? So if you say 61 seconds, you're sort of right, but you know, that's a minute and a second, correct? Keeping what I just said in mind, can you add those? It's an interesting take on carrying the one. So we'll see. There's a few different ways you could do this. Let me tell you a really nice way to think about this. How many seconds would it take to make that become a minute? 8. And I'm given 29 more, right? So how much over did I give?
21.
That's all I'm going to say for the moment. That's kind of a nice way to do this. Now is a great time to make mistakes, because I'm not even going to look at your shit right now. So just try something and see what happens.
You can't carry it because it's seconds to minutes, right?
Well, again, why do we carry a 1 in our base? Because our base is based on 10. This base is 60, so every time we hit a 60, I carry 1. Because it makes 1 of the next 2. Yeah. So that's why I said it was an interesting take on carrying the 1. What did I say? I can't remember. Oh, 10:30. Right. Okay. Good. Yeah.
The symbol for the second angle, what was that again?
Shit. I'm sorry.
Symbol for
Oh,
the-
alpha.
Alpha, and what is that, what does alpha mean? Like second angle would mean a measurement of angle?
So it's sort of like X and Y.
Okay.
What does Y mean? It's just another
It's just
variable we
another-
use.
okay.
So for some reason, we were like, angles are neat. Well, she's great. You know, so it's sort of like, anybody watch the Super Bowl? Ever? Back in the day, they would have Roman numerals. They would drop down in stone. Super Bowl 43, you know, it'd be the X, blah, 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 you know. And to me, it's funny, I thought for Super Bowl 50, does anyone know the Roman for 50? L. That's it. 50 is L. So it would have been Super Bowl L. It's like, no. So I think for Super Bowl 50, they just didn't do Roman numerals, but sorry. I can't even right now remember why I was talking about Roman numerals. But, so alpha is just a symbol we chose. Instead of X and Y, those are already numbers. Theta and alpha are for angles. Yeah. So let's see, let me line these up. 73 degrees, where do you go? 41 minutes, 29 seconds, plus 20 degrees, 8 minutes, 52 seconds. So one way to kind of do this is 8 plus 52 would be a full minute. So that's another minute. Do you see that? And how much is left over? 21. So I got 21 seconds. How many minutes do I have? 50 seconds. Sorry, 50 minutes. And then, of course, nothing carries. So if that would have went over 60 on this, I would have had to carry it again. Do you guys see that? Yes.
Not really to do with the question, but like minutes and hours. Like, are we like in reference to like real time?
Total.
Or is that just like a, oh, okay.
So so instead of hours to minutes to seconds, this is degrees to minutes to seconds. The reason we carried it over is because they're all based on 60.
No, I understand like how the metric of it goes, but I'm just like, how do we come up with that and like minutes and those? That's what I'm trying to wrap my head
So
around.
the Babylonians chose 360.
Yeah.
And they did some shit with it, and we were like, why would we? Let's just do what they did. So we stole that. And by the way, we stole all of our numbers from our. You know what our numeration system is? 1, 2, 3. Do you know what it's called? Hindu Arabic.
Oh, because the number of.
Because that's who created the symbols we use. We were just like, what do we want to use? Why don't we just use what these guys did? Yeah. So we just took that. So what's funny is there was a survey. People gave. It's not funny really. It's sad. They gave a survey to some parents. They said, "Do you want us teaching Arabic numerals in school?" And they're like, "No, that's 1, 2, frickin' 3." Wake the shit up. Anyway, sorry. You guys all okay? So we borrowed. I'll say it to be nicer. From every other civilization on the face of the earth to create what we use. It's just time that we start, saying, "Oh yeah, we took that." And then of course here I get 93 degrees. Good. So I do end up a little bit past 90.
Can you just give us an example of like what a question would be like? What like would it just be something exactly like this? And
It could either be a straight up algebra, like math problem. Whether you say these, or it could be like a word problem. Like I said, you rotate through this angle and then you rotate that angle more, which then is one step away from just add the damn things, right?
Okay.
It could even be a subtraction problem. It's really interesting.
Okay.
Okay. That's pretty good. I think I almost got as far as I wanted to. Let's do this. Let's hit the road, unless somebody has another question about what we've done so far. We haven't done too much yet, so that's kind of nice. You can totally start on section 1.1 homework if you haven't already. I did not make 1.2 a part of our curriculum. I might reference a couple of things in there, but it's more like straight up geometry, which we sort of kind of assume you've had before. So if that's not true, I will review a little bit when we hit certain things that you need from geometry. But section 1.2 is a lot of geometrical stuff that you should be coming in with. Okay, so do this for me. Gather all your stuff. Go out the door. Go this way very slowly. Wait until I get in front of you, and then I'll take you upstairs, okay? Because I got to pack up. It always takes me a while.